So this video discusses about on how we can come up with a regression line and there are some principles behind. So we understand that one of the ways in which the bivariate data can be presented is by using what we call as the scatter plot. Let's say we have, this is a typical scatter plot. Let's say we have a scatter plot somewhere in the array. This is x-axis and this is y-axis. Let's say these are the dots, and for the scatter plot as that. Let's say that is the case, and we discussed that a scatter plot can possess the positive relationship or the negative relationship based on the pattern in which the dots are actually portraying. Now for this case, this is a positive relationship, and let's think of connecting some dots that seems to be in line and to have the straight line. Let's say we have this case. Now in this case, as you can see it here, what you have, it's a straight line that is being drawn upon connecting some sample points that are in the same line in that way. So what we have here is what we call it as the regression line. We call it as the regression line. And as you can see, this is a typical straight line. And as far as you know that the equation of the straight line, it is given as y is equal to mx plus c. Then the regression line can also be presented in the same actual nature, but with some changes. Now the regression line is given as y is equal to a plus bx. Of course, this is also the same as y is equal bx plus a. So this is what we call as the general form of the regression line. So which means if we have the bivariate data, we can be able to draw the, we can be able to actually draw, so we can be able to come up with the equation of the regression line in actually this case. So even if the data, if the variables are negatively related, principle remains the same. We can have the regression line being oriented in other ways as well. Let's say we have, this is negative relationship, like that. We can think of having connecting some points that seems to be in the in the line, like that. So this is what we call as the regression line, and are being presented in the actually same way, only that since this is the positive relationship and basically the value of b is positive, since this b portrays the gradient of the actual gradient of the line, and where since this is the negative relationship, it means in all cases regression line follows this way. We'll have it as y is equal to negative bx plus c. Mind you, if you think of comparing this equation to the general equation of the straight line, we'll have it as y is equal to mx plus c, of which this is the gradient. So in this case, b is also said to be the gradient, and also in this case, b is also said to be the gradient. Now for the positive relationship, gradient will be given as positive, and for the negative relationship, the gradient will be given as negative. So that's how you start to understand about the regression line in terms of its general form. So keep in mind that the general form of the equation of the regression line is given as y is equal to a plus bx, or y is equal to bx plus a, and of which, how can you be able to have the value of actually b? Now the value of b is given as the correlation coefficient times sy divided by standard deviation for x values. And whereas that of for a is given as mean for y minus b times mean for x. So this is how we should have to understand all these cases. So which means we need to have the correlation coefficient, and from there we can be able to have the value of b, much as we have the standard deviation for actually standard deviation for y and also for x, like that. So make sure that before actually go for this lesson, you have gone through the lesson actually we discussed about or actually a correlation coefficient. Otherwise, this is a typical application of the correlation coefficients. So the general form of the regression line is given as this, where a and b are constants and they are calculated from the formulas. B is given as the correlation coefficient, and we understand the formula for the correlation coefficient is given as the summation of xi minus x bar times yi minus y bar, and divided by n minus 1. That is the formula for the correlation coefficient. And by the way, it should be not like, but should be correlation coefficient is given as covariance divided by standard deviation for x times standard deviation for y, and of which sxx, that is sxy, that is covariance, and it is given as summation of xi minus x bar times, and some active times yi minus y bar should be y bar, by the way, we should have it as y bar, and divided by n minus 1, and of which sx, that is the sample variance for the x values, that is the summation of xi minus x bar to the power 2 over n minus 1, and sy is also sample variance for the y values, that is the summation of, that should be y I minus y bar to the power 2 divided by n minus 1. So just a reminder, these are the formulas that are being used to have the value of the correlation coefficient, and from there you can be able to have the value of b as well as the a using this formula, and upon having a as well as the b, you can substitute into this actually equation. And for instance, if we have, let's say, a is given as, let's say, 2, and if b is given as, let's say, 0.5, so which means the general actually, it means the regression line will be given as, let's say, y is equal to 2 minus 0.5 x. It will be given as this in case if we have, let's say, a as 2 and b is given as 0.5. So that's how you start to understand about actually regression line. So make sure you understand about the concept of the correlation coefficient, and from there you can be able to have the regression line using that case. So we are saying, assuming a is given as 2 and b is given as negative 0.5, upon substituting these into the general form, we'll have the equation of the regression line being given as that. In some cases, upon having the equation of the regression line, we can be asked to have, let's say, the value of, dependent variable. If we have, let's say, some x is given as 5. So how can you have y if x is equal to 5? We just have to simply substitute y is equal to 2 minus 0.5 times that 5. So you can be able to have the value of y. And likewise, if we have the regression line, equation of the regression line, we can also be asked to have the value of independent variable x if we have the dependent variable actually y. Let's say y is given as should be 20, we can be able to have, the value of x corresponding to y20, much as we have come up with the equation of the regression line. So make sure you understand all these things. So I've left much of this week for you because I understand, you've gone through the regression. Okay, you've gone through the regression coefficient because that's the basis of whatever we're having here. So at your own time, try to come up with the regression line for the following data. Let's say if we have x and y like that, so we have 2 corresponding y6, we have 7 corresponding y, that should be, we have 3 corresponding y, we have it at 7, we have 4, 8, we have 5, 12, we have 6, 13, we have 7, let's say 5. So in this case, we should have to come up with the regression, actually equation of the regression line, and from there we should have to find the x when y is given as, let's say, 16, like that. We should also come up with x when y is given as 50, and also we should come up with sort of y when x is, let's say, somewhere about 12. So try to have that at your own time, and also try to come up with the equation of the regression line with the following. Let's say if we have the data values given as 3,6, and we have, let's say, 5,8, and let's say have 2,6, sort of like that, and let's say have 1,4, and let's say have 4,7, like that, and we have 4,6. Now we should have to come up with the equation of the regression line, and hence we should have the value of x. We should have the value of x when y is given as, should be 25. So how should you have that one? So you should have to try that one as well, and also try to come up with the value should be the equation of the regression line. If we have, let's say, this case as well, we have the data x and this is y, where we have x1 5.6, x2 we have somewhere about 4.6, we have x3 we have about 4.5, and x4 we have about 3.7, sort of. We have 5, that is about 3.2, we have 6, that is about 2.7. So try to have the regression, equation of the regression line, and from there you should have the value of x when y is given as, and that should be 15.6. we should also have the value of x when y is given as, let's say, 17, like that, and I also should have the value of y when x is given as 10, and also the value of y when actually x is given as, and that should be 15. So try to have that. Now in some cases, let's say we have the regression line which is given as y is equal to negative 5.6 x plus 2. Now looking at this actually regression line, it means the value of b is actually negative, which is negative 5.6. So since b is said to be the gradient as well, so which means the graph of this line, the graph of this regression line, it is somewhere like this. It means there is actually a negative relationship between x as well as the y. So how can we come up with the sketch of the scatter plot for that case. So given the regression line, given the equation of the regression line, you can only be able to come up with the sample of the scatter plot if we know the nature of the value of b. So now in this case, the nature of the value of b is negative, so it means there is a negative relationship, of which the sample of the regression, actually the sample of the scatter plot, can be given as this, since it is a negative relationship. It can be that. So basically you can be told to come up with the sketch of the scatter plot if we have the regression line. So your attention has to be on the value of b, which is the gradient. It tells whether the line is a positive line or negative line. And how about if we have this? Let's say if we have the y is equal to 0.5x, let's say minus 2. So what is this? So now in this case, since the gradient is positive, it means the regression line is going like this. That is actually positive relationship. Then you can be able to come up with the sketch of the scatter plot in that way. So that's how you start to understand about the regression line and the principles behind it. And also try to have the regression line, equation of the regression line with the data below. We have x and we have y. In the x we have 2, and we also have 2, we have 3, 4, let's say 1, 5, and that is been given as, let's say 95.55. Let's say that is the case, and we have 110, should be 0.19, we have 118.92, we have 150 point, let's say 67, and let's say we have somewhere about 85.97, should be 67, and we have 180.99. Try to have the equation of the regression line using that data. Thank you.